Problem 40, mates. You're probably here because, this shit's just fucking hard. It's fucking bullshit. And, it's just so much fucking work. Fucking hard. Alright. So right here on this, it's telling us to calculate the total force on the Earth due to Venus, Jupiter, and Saturn. Assuming all four planets are in a line and their masses are as followed. Mass of Venus equals 0.815 times the mass of Earth. And to find the mass of Jupiter, 3.18 times the mass of Earth, and find the Saturn, same thing. And their mean distances from the Sun are 108 kilometers, which means that Venus is 108 kilometers away from Earth, and then from the Sun, and 150 is the mean distance from the Sun for the Earth, 778 is the mean distance for Jupiter, and 143 billion kilometers is the mean distance from the Sun for Saturn. Alright, so we have to calculate the total forces. So if I warp over to my mate's work right here, I see how I drew a diagram, drew all the forces acting on Earth. So we know that the gravitational force on Earth is exerted by Venus to the left, and the gravitational force that the Earth is feeling by Saturn and Jupiter is to the right, as you see right there. So right here, I just calculated the masses, alright, kg. So the mass of Venus, 4.8737 times 10 to the 24 kg. Just some easy stuff. Calculated all the masses. Mass of Venus, Jupiter, Saturn, and Earth. And then it already gave us the mean distances from the Sun, from their centers. So you just have to change that to meters. So radius of Venus to the Sun. And then as follows: Earth, Jupiter, and Saturn. Alright, change that to meters. And now this is where it gets, fucking hard. Alright, so it's telling us to find the gravitational force. And the reason why we're trying to find the gravitational force is because we're dealing with two particles. Alright, first off, we're going to start dealing with the Venus and Earth. The force that's being exerted on the Earth by the Earth by Venus. Alright, so that's what I'm doing right here. So the force on Earth exerted by Venus equals the gravitational constant G divided by the mass of Venus times the mass of Earth divided by the radius square, which is the distance between Venus and the Earth. Alright, and how I found the distance between the Earth and Venus was I subtracted both their distances from the Sun, and whatever that was my radius between those two objects. Because in this, it tells us the distance between 2 points. If we were to use the distance from the Sun of each of those planets, it wouldn't follow as the distance between those two. Instead, it would be the distance from the Sun here and the Venus here, the distance here. Instead, we're trying to find the distance between these 2 points, and that's why I subtracted the distance from the suns for both of them. Alright, so once we find our radius right there, which I got 4.2 times 10 to the 10 meters square. Alright, we just have to plug everything in, some simple stuff. Venus, we have Earth right there, the mass of Earth, and then we have a gravitational force on Earth, which is 1.1 times 10 to the 18th newtons. Alright, so that's one of the forces, or that's one of the forces in which that's one of the planets that's exerting a force on Earth, or gravitational force. Now we need to find the gravitational force of both Jupiter and Saturn. So we have to pretty much do the same thing as I did up there, subtract the distance and the mean distances from the planet to the Sun. Alright, for both the Earth and Jupiter. We're still doing the Earth because we're trying to find all the forces exerted on the Earth. So force on Earth exerted by Jupiter equals gravitational constant, parentheses, 1.9 times 10 to the 27th kg, which I said right here was the mass of Jupiter. Alright, and then the mass of Earth given to us divided by the radius, in which I said it was the radius right here, which I said was the distance between Earth and Jupiter from their centers, alright? And I get a gravitational force of 1.92 times 10 to the 18th newtons, alright? And that makes sense why the force on Earth exerted by Jupiter is greater than the force on Earth exerted by Venus, because look at the mass of both those planets. The mass of Jupiter is 1.9 times 10 to the 27th kg, while the mass of Venus is 4.8737 times 10 to the 24th kg. So we know that Newton's gravitational law, the mass and the gravitational force are proportional. The more mass that we have, the greater the gravitational force will be. Alright, even though it does have a greater radius or distance between them, however, it does have a much larger mass, so we should have a greater gravitational force. Alright, so now, oh fuck, where's my other work? Jesus. Oh fuck, here it is. Alright, so now I already found the two forces that's being exerted on the Earth. I already found the force on Earth exerted by Venus and the force on Earth exerted by Jupiter. Now I need to find the force exerted on Earth by Saturn. So then I'm just going to go here, same thing. Alright, so now I already found all my forces. Alright, all my forces acting on the Earth. Alright, which I said right here, we said 1.92 times 10 to the 18th newtons, which was the force exerted by Jupiter on the Earth. And then we have 1.22 times 10 to the 17th newtons, which is the force exerted by Saturn. And then minus 1.1 times 10 to the 18th newtons, which is the gravitational force exerted on Earth by Venus. Why do we subtract it? Well, because I look at the direction. The Venus is pulling on the Earth in the opposite direction as both Jupiter and Saturn. So we add the forces exerted on the Earth. We add the forces of Jupiter and Saturn, because they're both going in the same direction, and we subtract the gravitational force of Venus exerted by the Earth. So once we do that, we get 9.42 times 10 to the 17th newtons, in which we just answered our question. So calculate the total force on the Earth due to Venus, Jupiter, and Saturn. So we just did that, and we are hella fuego. We are hella fuego. We just got it, 9.42 times 10 to the 17th newtons. So that's the total force exerted on the Earth by Venus, Jupiter, and Saturn. Alright, so that's my total force right there. So just on these problems, you need to know all your knowns and just really pay attention to what it's asking you. Draw a diagram, as I did right there, so you won't get all mixed up. And the reason why we wouldn't use the little g one, the g equals gravitational constant, mass of one object divided by the radius square of that, because we're not dealing with objects at the surface of its Earth. Instead, we're dealing with two objects, as we see right here: Earth, Venus, Earth, Jupiter, and Earth, Saturn. We're dealing with two objects, and we have a distance between them. They both have masses, so we're just trying to find the gravitational force that one object exerts on another. We know that same force is we know whatever that force is the same force or equal as if, so the force that Saturn exerts on the Earth is the same force that the Earth exerts on Saturn. Newton's third law. So that's some gravitational stuff. But either way, I know you're always going to use this one. We're talking about two objects, and we're trying to find the force, the gravitational force. Alright, if it was finding this, just going to use this. So, you should get that, 9.42 times 10 to the 17th newtons. And if you really want to get fancy, you want to find the fraction. If you want to find what's the fraction of the sun's force on the Earth is this, then we have to find the force exerted on Earth by the sun. Alright, gravitational constant, mass of Earth, no, mass of sun, mass of earth divided by the distance between them. All right, and we get a force exerted on sun, a force exerted on earth by sun equals 3.53 times 10 to the 22 newtons. That is a lot. That is a fucking shit ton of fucking gravitational forces the sun's exerting. It's why is it greater than both? Why is it greater than the force that's exerted on Earth by 3 planets? Well, look how fucking massive that shit is. Look how massive the sun is. 1.99 times 10 to the 30 kg. That is huge. That is fucking huge as fuck. And look at the distance between them. The distance is much smaller, right? So it's more massive. Remember how I said, even though the radius square is inversely proportional to the gravitational force, but look how massive the sun is. It's freaking massive. So it's proportional to the gravitational force. All right. So then, once I find that the force exerted on the Earth by the sun, I just really have to divide it by the force that's being exerted on the Earth by those 3 other planets, and then I'll get my fraction force, which will be get my fraction force like that. So this shit should be pretty simple now. Should be hella fuego if you see another problem like this. And yeah, hella fuego. Cool.